this video is about converting from a non-grid projection to a grid projection. So I went out and did this 40-acre survey yesterday in Magdalena, or south of Magdalena, New Mexico. And I did it in ground without any known projection. So what it does by default is uses a stereographic projection at ground distances, which is great because the stereographic gives me GNSS north, which is pretty much the same as magnetic north or true north. It's very close to it. So if you want to just start a survey and go from one found point, that's the way to do it. But then after you're done and you need to bring it into other systems that use named projections, you can convert it after the fact. So first thing you're going to do is go into the survey menu in Survey Pro, go to projection, and then go to switch to mapping plane. Before I do that, I'll just show you under the details right now that it, based off of my position right here, the latitude and the longitude, and then using my ellipsoid height, it calculates a ground scale using a stereographic projection. That's in German, but it means stereographic. So I can go switch to mapping plane. You already have a projection defined. You will have to reset. Okay, that's fine. Now I'm going to go ahead and do select zone and select the appropriate zone for it. I did an Opus position and it's not ready yet. So I'm going to go ahead and go to the NCAT site, which will show me what zone I'm in. So then I select what zone I'm in, which is New Mexico Central, and I verified that using the NGS utility NCAT, when you can put a lat and long in and then get your zone. Now I hit finish. Now I'm in a grid projection, but I want to be in ground distances. So if I just go to my map view real quick and just go over here, select a point, or select a point here. Let's look at one of our Brascaps. I looked at it has a northing and easting now that are grid. And now it's not showing me any ground coordinates right now. So to get those ground coordinates, I go over here, again into projection, mapping plane ground, use ground coordinates. We're going to use our base point to be our origin, so that's going to be 0.50. Hit next. Here's where it gave us our calculation based on that ellipsoid height. And that looks right. 130379688. Go next. Now we're going to hand copy 1097189.603 and then copy the easting 1342564.028. Should be nearly 0 when it compares the next screen, and it's showing us our scale. Now we hit finish. Now if I go in here, well, let's do one more thing. Let's solve calibration. Okay. Now if I go to any one of these points and I want to see the coordinates, you're going to see differences grow as you get away from your origin point. So the further you are away from your base point, the larger these coordinates are going to be different. But you can see it's only about 1/10 right now in difference from the ground to the grid. And as you go further away, it gets bigger. That's how you do it.